You've already seen that magnets can exert forces on other objects from a distance. So I can bring a North Pole beside a North Pole and they will repel without touching. Or a South and a South together will repel, again without touching. But a North and a South will attract. This is because magnets have something called a magnetic field, which is a region of space where magnetic materials will experience a force. You've already seen that the Earth has a magnetic field, and to identify its direction, we can look at a compass. So there's a compass, and we can see that north in this direction is that way. It doesn't matter which way we point the compass, the needle will always point in the same direction. However, if I bring a magnet towards that, we can see it's going to change the direction because the compass needle will line up with the magnetic field that's strongest. In this case, it's the one of the bar magnet. So now it's lined up with the Earth's magnetic field. And we can use a compass to allow us to see the shape and the direction of a magnetic field around a bar magnet. So I'm going to use a different type of compass. This is a plotting compass, and I can put several plotting compasses down. And you can see that they all point in the same direction. They're all pointing that way, which is north. However, if I put a bar magnet down, you can see they all change direction, and they're pointing in different directions. This one's pointing that way, that one's that way, that way, that way. This one's coming that way. So the direction of the magnetic field around the bar magnet seems to be in lots of different directions. And so what we're going to do now is we're going to find out what is the shape of the magnetic field and what direction it's acting in. First thing is I'm going to draw around the bar magnet. And I'm going to label which end was which. This was north and this was south. Now I've got a plotting compass, and we can see it's pointing to the right in this case. And I'm going to mark the direction of the arrow of the plotting compass by putting a dot there, taking it off, and joining it with an arrow. The plotting compass is showing the direction of the magnetic field. And what I'm going to do is I'm going to put it at the end of that line. And I'm going to keep on moving it so we can see the direction. And you can see this is coming out in a straight line to the right. If I do the same thing at the south end, see this time it's still pointing to the right, it's still pointing towards the south now. So far, everything is pointing in the same direction. If I put it at the corner, you can see it's pointing in a different direction. It's pointing up and to the right now. There the line's not so straight now. I'm going to continue doing this around the magnet and see what happens. And we can keep on going, but I'll stop there. And what we can see is that we're getting these distinctive loops coming out of the north and back into the south, out of the north, into the south, out of the north into the south. The magnetic field of a magnet is always acting away from the North Pole and towards the South Pole. We can also see that the lines spread out as they move further away from the magnet and they get closer together at the poles. The lines represent the strength of the magnetic field. The closer they are together, the stronger the magnetic field. So here we can see that the magnetic field is strong at each pole, weak further away, but it always acts from north to south.